Good morning, everybody. Welcome to Black Hat USA 2015. I hope you've all had a good morning so far. Welcome to Internet Plumbing for Security Professionals, a presentation about BGP security. Your speaker today is the Manager of Strategic Services for Rapid7 in Europe. He is the organizer of the BrewCon conference, co-developer of the Penetration Testing Execution Standard, or PTES, and former board member of ISC Squared. Without further ado, may I please present to you Mr. Wim Remes.
Good. So do you guys, have you guys watched 8 Mile? You know that moment where Eminem is going to battle for the first time? That's about how I feel right now. So bear with me. I didn't eat spaghetti last night, so that's okay. I've never had a keynote that segued that well into my presentation. The reason why I started looking into BGP security, or BGP in general, is because I believe it's a foundational element of the internet as we know it, and securing BGP is important to build the trust in the network. As security professionals and as IT professionals, we tend to use simplicity. Basically, we abstract away all the complex things about the networks and the applications that we try to secure, and we try to talk into general terms. I think at certain points we need to be aware of the complexity that constitutes our networks, how we can secure them, and basically how we can provide our users with a secure and reliable internet. And that's basically what my presentation will talk about today. In short, the agenda for today, I've tried to keep it simple and straight. We're going to go through the history of BGP security. Then we're going to talk a little bit about the BGP threat model to put everything that I'm telling about BGP and how to secure it in perspective. I try to document why do we actually care as security professionals, as network owners. I assume some of you in the audience are network owners or work for network owners. And then how do we get better? We're definitely not at a point with BGP security right now where we are in a good state. Otherwise, my talk wouldn't be here, right? So there's definitely calls to actions on how to get better and how we as security professionals can force network owners to be better. I'm also trying to avoid any buzzwords like cyber or there is no life hacks of vehicles or whatever on this stage, but you can have those later in other presentations. The one word I will use is the Internet of Things, because that for me clearly illustrates what I and other professionals call simplicity. We really want applications and stuff that people want to buy on a network as soon as possible, but we forget about the underlying plumbing. And basically, that's the reason why I called my talk Internet Plumbing. The plumbing for the Internet of Things is the same plumbing as it existed back in the day when the Internet was born, right? The problem is that today, everybody that uses the Internet has an expectation of security. It's not the Internet of Things, it's the Internet of your things. However, there are different stakeholders in the Internet of Things. You have the network owners that run the networks. You have the application developers. You have service providers. You have big commercial organizations. You have the end users. And the incentives to make the network secure are not properly aligned. So the people that actually have the power to make the network reliable don't have the incentive to invest in that, right? So I want to turn the Internet of our things into the Internet of doing the right things. So it's not only about doing things right, it's often also without sufficient incentives to just do the right thing to make sure that the Internet that we use is actually a reliable and secure Internet. And that passes me out of the introduction into the meat of the presentation. First, we're going to talk a little bit about how BGP actually works. So BGP is a border gateway protocol, and I refer to ASN owners, autonomous system owners, instead of ISPs. In the past, there was almost a one-on-one match between ISPs and ASN owners. But nowadays, big corporations own their own autonomous systems, and they are not specifically ISPs. So we talk about ASN owners. ASN owners build peering relationships with other ASN owners to exchange routing information. And BGP, in its essence, is a very simple protocol. Once that peering relationship is there, the routing information is sent to the peer, and they accept it given certain policies. So in this example, you have 4 autonomous systems, and specifically, AS101 will say, how do I get to the 1070 network, right? And it will get routes from its peers. And right now, the preferred route, and just because the AS path is the shortest, that's the only thing that BGP concerns about. They are not concerned about, BGP is not concerned about bandwidth or any other technical parameters of the link. It's only the AS path decides which link is taken first. So in this sense, AS101 knows that it can go through Autonomous System 102 to get to the owner of the 1070 network. But then AS104, who owns the 1070 network, can decide that the link to 102 is too expensive. They're paying for both links. They're paying more for the link to 102. So what they do is prepending. And then you will see something like this. So they just add their own AS number several times to the path, and then it appears longer. And BGP doesn't care. It will just say, okay, this path is longer, so I'm not going to use that one. I'm going to use the shorter one. And then the real security about BGP is built into the routing policies. And this is where autonomous system owners decide what to do with routing announcements. For instance, a peer could be allowed to announce a route to a /16 prefix, but when they use the same IP range or IP prefix with a /24 or a /30, they will not be allowed to do that. There can be filtering on reserved prefixes. There can be filtering on attributed prefixes, or like I just said, to specific prefixes as well. So it's very, very important to remember, once the relationship between the autonomous systems is established, they will technically accept all updates from that peer. There is inherent trust between the peers. And that's one of the main things about BGP. The trust is everything. If peers trust each other, anything can happen. And we have seen that witnessed in several examples throughout history. And it started back in 1997. One of the first events that happened was the AS7007 hijack. What's important to note, if you look into BGP incidents, it's very hard to see the difference between a malicious BGP attack and an accidental misconfiguration. It all looks like a prefix is announced by a peer, and that propagates through the network. So it both looks the same, and you can only look at malicious motivation based on the kind of traffic that is rerouted and what is then eventually done with it. But on the BGP event itself, it's very hard to tell whether it was malicious or intentional. In 2008, there was a country called Pakistan that tried to limit YouTube access on their internal in-country network. But accidentally, they started announcing YouTube prefixes, so they basically attracted the traffic from YouTube to their network. That would have been an example of a non-malicious route leak. We've also seen China do the same. And okay, China was my first buzzword for today. I'll try not to do it again. China in 2010 also announced a lot of prefixes they were not authorized for, and they basically attracted traffic to Facebook and other websites that people use regularly. Most recently, earlier this year, there was a Malaysian ISP that announced a lot of prefixes to level 3 as a network operator, and level 3 propagated that information to the rest of their network, which basically told a lot of the internet that traffic needed to go to that Malaysian ISP. And added complexity there was that the Malaysian ISP announced so many prefixes that they were basically overflowing the routing table of the level 3 routers. So those routers started to reboot, and that created a lot of bad news on the internet because of latency, and traffic wasn't going through because the routers were rebooting. And then most recently, I think about a month ago, there was evidence of a commercial organization that lost access to a server on a network that was owned by an ASN that went out of business. And they decided to collaborate with an ISP in country to basically announce the prefix of that ASN, the prefix they needed. And that ISP decided to work with them. If we see more and more of that type of events, and I think in the age of surveillance and creating a trusted internet, I don't think we can benefit from seeing more of that type of events. And that's why we're going to talk more about BGP security and how to secure BGP networks. So in essence, when you look at BGP, it's a very, very brittle and very simple protocol. But it's also very simple by intention. It's simple by design. Because if you have a protocol that is basically the backbone of the internet, you don't want it to be too complex and too complicated. You want it to be simple and flexible. And when you design simple and flexible, you don't design for security. And there are reasons for that. If you look at, traditionally as security professionals, we look at worst case scenarios. And we look at BGP and see it's not authenticated and we are able to man-in-the-middle it. But in essence, really, the attack surface is fairly limited. So for instance, a denial of service attack against a BGP router is possible, right? But most ASN owners have multiple BGP routers and pair with multiple autonomous systems, other autonomous systems to create a failover network, right? So denial of service can be an issue, but most of the organizations that own autonomous systems have already built controls in it. And those controls don't need to be in BGP itself. Then you have router impersonation, which is also possible. It's very easy to download an open source BGP router and set up your own BGP router. But it's still difficult to get an ASN and to get access to a link that basically allows you to first perform a denial of service against the router you want to impersonate, and then create a peering relationship using the same IP address as that original router to connect to its original peers. There's a lot of complexity and prerequisites to execute an attack. Then there's a possibility of whatever you want to see as a big service, whether that's AWS or Google or Azure or whatever valuable service for an organization, using BGP hijacking. Now we have to know that everything is possible, but not everything is probable. So when we as security professionals, I think there should be another talk about how we define risk and how we work with risk. But right now, the most popular equation is still impact times probability equals risk. So there is limited probability of the attacks that I'm describing, but the impact once they happen is huge. Not only in the short term to the directly involved parties, which could be your employer and another third party or several ASNs, the ISPs that basically have to rebuild trust with their peers, but in general, in the long term, in the trust in the internet. The main attack that we're talking about when we talk about BGP is route hijacking. Route hijacking is where an ASN owner announces an IP prefix that they are not authorized for. What are the possibilities to do that? You could get direct access to a router. There definitely are router 0 days, or routers can get hacked at a certain point. Most of the time when we see somebody getting access to a router, it's mostly through a routing management computer, either by collusion with somebody that works at an ASN or a network owner, or by using a method to compromise one of those computers and then use their access to get access to a BGP router and inject a route there. But like we saw with the Italian example earlier in my presentation, collusion is a very big thing there. And I think ASN owners should be given tools to define trust between the different ASNs they peer with, and I think that's possible with the technology I'm talking about later. So now exactly why we as an audience here in this room today, why do we care? Because BGP, I remember when I was starting in network security back in the late 90s, I was exposed to BGP, but most of the network professionals I worked with didn't have a clue what BGP was. It was basically the territory of the CCIEs of this world, and nobody would care. But the truth is that BGP is foundational technology. It's equal to, for me, is equal to DNS, SSL, TLS, HTTP, and all the technologies that allow us to use the internet as it exists today. The problem is that we expect it to just work for us. But we have no liability with the network owners. And just working depends on those ASN owners or the network owners. So we need to be able to build an internet that we can trust. The most mind-boggling thing that I discovered when I was looking into BGP and BGP security in general is that there is security technology that exists right now. And it's actually very easy to implement. But you don't see it used that much. One of the things that could be considered is router authentication. We talked about router impersonation earlier, and we as security professionals will immediately say, okay, it's MD5, and MD5 has been hacked, but it's better than nothing, right? If I have two routers that are not authenticating with each other, it's much easier to impersonate them than when they are actually authenticating. And it's very complex to do a man-in-the-middle attack to get the MD5 to get the MD5 hash. So it's still better than doing nothing. And then there's something called resource public key infrastructure. Is anybody familiar with RPKI in this room? Okay, that's good. So resource public key infrastructure basically is a technology that that's very similar to SSL TLS. So you have CAs. In this case, the CAs are the regional internet registries. They provide certificates which allow network owners to sign the IP prefixes they want to announce. So the local or the regional internet registries are ready to use this technology. All modern router technologies are able to use RPKI validation in their routing decision workflow. There are open source and freely available RPKI validators. The problem is adoption rate, and I will have some stats later. For some reason, the network owners don't think, or most network owners don't think there is an incentive to actually do this. Now, still, why do we care? For us as security professionals that work for organizations, it's not only about your own infrastructure that is hosted on IP networks. It's also about third-party high-value services you use. You want to know that those ASNs are, or the IP prefixes that your cloud infrastructure is hosted on, that those are not being hijacked. I think BGP information, and there are some examples later of tools that have been developed using BGP information. I think BGP information is very valuable from a threat intelligence perspective, because it allows you to rate the networks that you are connecting to know if the third parties you're working with are actually hosted on reliable, trusted networks, and then using BGP information to see when a hijack is occurring, to be able to react swiftly, is very important. So now we come to the stats that are sobering. So there is an RPKI dashboard that is freely available, and you see that less than 7% of the current IPv4 space, which is a shitload of IP addresses, is currently signed or has a validation status. You notice that there are 3 possible validation status. It can be valid, it can be invalid, and unknown. Unknown is basically the unsigned space. Now, on a global level, less than 7% of adoption of a technology that is established, that is known, and that can be used right now is poor. And that's basically the key about my presentation. I think ASN owners can do more to adopt RPKI much faster. Now, on a regional level, you see that it's still poor. And I don't trust the stats in this slide that much because you will see, for instance, that Latin America is supposed to be the leader when it comes to valid routes. It has the highest percentage of valid routes, but it also doesn't host that many IP ranges, right? And then on a per country level, we can be happy that the US is still in the top 4, but it is preceded by, who knows what the TLD BD is? No, it's Bangladesh. So the leader when it comes to RPKI implementation is Bangladesh at the moment, followed by France, Holland, and the US. There's nobody below that. What is interesting to see is when we look at the Alexa Top 500, which are basically the top 500 used websites on the internet. Only one of the top 10 hosts IP addresses in signed space at the moment, and that's Facebook.com. That has nothing to do with Alex Tamas, who has a mission to secure the internet, but it's probably something he's thankful for, that he doesn't have to address that with Facebook right now. Then there's the top 500. Only 16 of the top 500 websites are hosted in signed space at the moment. And that basically means if you look at BGP as the plumbing of the internet, that most of the top 500 websites are hosted in untrusted, unsigned space. So 2 of the 16 are owned by Facebook, their main site and their CDN for all the videos and cat pictures that you watch all day, and then the crazy pictures that some people here post on my timeline. So most of the websites that are in signed space are outside the .com space. And you remember from this site, when we see it, when we look at US, most of the assumption is that .com equals US. Because there's no real way to say what US constitutes on the internet. The internet is American, right? So we come back to the internet of doing the right things. How are we going to incentivize network owners and service owners to adopt RPKI? First thing is to understand RPKI. When you do RPKI, like I said, the regional internet registries will assign certificates to network owners and allow them to sign the IP prefixes that they are allowed to announce. That includes not just the prefix, but also the maximum length. For optimizing reasons, prefixes are often cut in smaller chunks, right? And the ROA or the route origin attestation tells the verificator that this is the subnet or the IP prefix that I want to announce, and this is the maximum length that I will announce it with. And then anything in between there will be allowed. So ASN owners request those ROAs from the regional internet registries, and then something like this goes on. So you see in this picture that AS103 suddenly announces 10.10.1.0/24, which is a more specific subnet of the 10.10.0.0/16. And I'm going to switch between this slide and the next slide a little bit. So these are very ghetto routers. AS103 will say, okay, I have a route to 10.10.1.0/24. And because there is a trust relationship between 103 and 102, 102 will record that announcement and start routing traffic to AS103. However, when RPKI is implemented, the 102 will talk to its internal validator or a public validator that is available. And will ask if 103 is authorized to announce the prefix that they just announced. The validator will say, no, it isn't. And then ASN 102 can still do whatever they want. They will know the validation state, and they can introduce the validation state as an additional decision in their routing policies. And that's where RPKI allows an ASN to create different levels of trust with their peers. You can have peers that you have a long-standing relationship with, that you have shared incentives with, where you see an accidental, non-validated route, that you can still accept it. But when you start working with a new ASN, maybe out of a region that you're not familiar with trusting, you can implement very strict routing policies and basically say, if they announce a non-valid route, I will drop it and not propagate it to my other peers. So we talk about an RPKI validator. And for once, and I've worked in different areas in security that have the same problem, but for once, we are not looking at different vendors trying to set different standards for a certain technology. There is an open source RPKI validator that is developed by RIPE. So we're not looking at a big vendor. It's basically the people that run the internet came with a solution, and it works very well. I've personally implemented it, obviously in a test network, in less than 50 minutes. The only downside is it requires Java 7. And you're, okay. There's nothing you can do about that. Since it's open source, I invite anybody that's interested to collaborate on creating a non-Java versions. I'm happy to work on that as well. But for the time being, we have to live with Java 7. Then you configure routers to use the validator, and then you're basically done. From there on, it's just configuring the routing policies. Now, monitoring. I'm aware there are commercial solutions for monitoring. You can subscribe to BGP monitoring tools that are commercial, where you basically enter the IP prefixes that you want to monitor. That can be your own, but it can also be IP prefixes of services that you are depending on. And then you will get alerts. You will get a BGP dashboard, and you will basically get a BGP threat feed from that commercial organization. But during my research, I stumbled across the University of Colorado, and now it's very confusing. The best commercial technology for BGP monitoring is also called BGP-Mon. But people in BGP are not generally creative people. So the best open source monitoring solution is also called BGP-Mon. Try not to confuse both. So the people at the University of Colorado, they peer with different ASNs and basically get routing updates from those ASNs. They provide a dashboard on bgpmon.io. They also provide open source BGP monitoring software that you can download, install on your own infrastructure to do the analysis on your own infrastructure instead of relying on the BGP-Mon service. And then there is the live BGP service, where you basically get a real-time XML feeds that they extract from the routing updates they get. I think it's a very good service, and if you're an ASN that is interested in creating an open source or collaborating with an open source and active BGP monitoring service, then I would strongly suggest to get in touch with the people at the University of Colorado to do that. Now, from most commercial organizations don't have an idea about how else they can use BGP monitoring technology. But a very good example that I've come across is the initiative by Circle. And I didn't know I had a long history with Circle, but I'll keep that for a side conversation. Circle is basically the Computer Incident Response Center of Luxembourg, and they created the BGP ranking tool. It's also a dashboard that you can consult on their website, but the technology can also be downloaded and you can use it in your own threat intelligence feeds. What they basically do is take BGP information, basically which ASNs own which prefixes, and they correlate that with information from, for instance, the SANS D-Shield public service, then all the SSH and email blacklists, and they basically look at all the badness that is on the internet, correlate the IP addresses that are that they derive from those indicators of compromise, and then basically rank the different ASNs. And then you get different interesting pictures, such like this one. So, you know, for the past year, we've all been yelling China, China, China whenever something happened. If you look purely at the BGP ranking data, the most offending countries on the internet are Russia. You see Poland as well, the US and Brazil. But China, purely in number of ASNs that they host and the badness that is found on those, that is publicly known on those networks, they are not doing that bad. The one caveat that I want to give is that the top two of ASNs that is consistently on the top two are two Asian ASNs. So when you have data skew and not improper correlation, you might not be looking at the right data. So in this map, China looks good, and that's funny because we're always talking about China being the bad actor. But you can basically use BGP ranking to do other things that are valuable for you, right? You can download the BGP ranking tool, take their data and complement that with IP or BGP data that you have, and actually create intelligence for yourself. So maybe a big thing is don't rely on somebody telling you which data is important to you. Try to get as much data as you can and derive what is important for you from there. Then we have other technology services that organizations can use to monitor BGP. So Hurricane Electric provides a BGP search site which allows you to look at the peering relationships between ASNs, which IP prefixes they use, and which is obviously very, very useful. Then there are organizations like the Team Simru, and I don't know if I pronounced the name right, but they are an independent sort of security professionals, basically, that also provide a lot of information about BGP on their website. And then obviously, I think there's one valuable commercial BGP monitoring solution that you could consider, which is the BGP Mon service. Now, in conclusion, again, I think BGP is important for everybody. It's not just network owners. In the end, it's about us as security professionals to create trust in the internet, and we should look at BGP on a much deeper level instead of abstracting it away. We have to look beyond direct incentives. In any ecosystem that has multiple players, incentives will not always be aligned, but there's also doing the right thing. If we want to create a trusted internet, we have to look beyond those direct incentives and look at doing the right thing and doing it at the most efficient way together. So we talked about RPKI, how it works. The technology is available. Problem is that we're not using it. So we should definitely try to see more RPKI adoption in the next few months, years. To give another stat, RIPE currently estimates, knowing that there is about 7% adoption in the IPv4 space right now, They are projecting 50% adoption of RPKI by 2020. I'm an idealist, but I think we can do better than that. So I will be monitoring the RPKI dashboard to see if there's more adoption after this talk. I don't hold much hope, but I need something to live for. And then, last but not least, let's work together to make this happen. I hope. I'm never a person that thinks that when I stand on a stage and talk about something, that's the end of things. I like to think that me standing on a stage talking about something is the beginning of something, and that we can actually do this together to make a better and more reliable internet. Thank you very much for your attention, and if there are any questions, I'm happy to take those. I think they're going to come with a mic for you. I hope so.
Wim.
Oh, yeah.
So I have a question about the RPKI validators. That looks like a centralized place where all the ASINs have to talk to. And so I guess the question I have is, what about availability and also synchronization among multiple validators across the
so the RPKI validator I talked about is developed by RIPE. It gets its validation information from the different regional internet registries, but it can be implemented separately by the ISP or by the ASN owner. So every ASN owner can implement their own validator. There is no centralized validation structure.
Okay, so if one goes down, you can redirect to another validator?
Yeah, you can do that.
Okay.
You can use standard, if you implement the RPKI validator on Linux, you can use standard load balancing tools and clustering tools to create basically a cluster of validators instead of a single point of failure, definitely.
What about using the existing tool like RedDBs or any routing database?
You can use those as well, but it's going to make it more complex for you, right? If the tools are there and available, you can use other tools as well, but I've not specifically looked into that one.
Okay.
I guess two questions. One being, this is kind of a chicken or the egg type issue. So if not everything's signed, why would I want to go through this? And even if it is signed, who's actually using it to validate it? I guess the second part of the question really comes down to, is there any type of performance impact when you start adding all these additional metrics to how you're doing your routing and routing tables?
So first about the performance impact, in all the networks that I've worked with, and there's both lab environments and then ISP environments, there was no direct performance impact on validation. The key about validation is that it's an additional step that people can, or an additional point of information people can use in their routing policy implementations. In the end, RPKI only starts being applicable when you look into in the routing policies. In itself, it will not change anything about routing, but it allows ASNs to be more specific in their routing policies. And I think that's where it's important. And once adoption starts to rise above a certain percentage, and I've not defined what that percentage is, there will be more ASN owners that take validation information into their decision workflow.
So it's my understanding that RPKI has kind of leapt to the top of BGP security solutions, seems to have the bigger bang for the buck, but I know several years ago there was BGP sec. Is that just moving along more slowly, or is it a fact that RPKI provides more security benefits or easier implementation?
I think it's definitely the ease of implementation and the fact that it provides more security benefits than BGP-SEC specifically, yes. There has been a competition between different standards, like you say, BGP-SEC, RPKI. I think the only luck that we can give ourselves is that it has not been a competition between vendors. which we have seen, for instance, in when you look at log management, different vendors have been battling on the standard for log formats. We have not seen that in BGP, luckily.
You talked about an open source validator for RPKI. How many of the commercial tools have implemented validators like SolarWinds or other network management tools?
I'm actually not aware of any commercial validation solutions. So I'm aware of the RPKI validator, but I'm not aware of any commercial validating solutions.
Isn't it worth to put this extra level of complexity for doing a solution for a fairly briefly problem? So the best practice on IT security should be keep it stupid and simple. Mm-hmm. And by adding a PKI infrastructure to all of that, it couldn't be possible to open an extra attack surface on ISP services, reputation services, taking over validators, injecting malware, exploiting this stuff, and so on. So to add more complexity to a solution that don't need to be solved, because it's working fairly good if you block multi-hop BGP and you're running right fairly and take care of your filter lists and your accepted ASNs. So to run a strict BGP setup.
So yes, that's a very good question, and I'm very very much a proponent of keeping things simple. But like Jennifer said in her keynote, there is no software liability. Right now, there is no network liability either. It's very very hard to blame somebody for something that goes wrong on the BGP level. And I think in that sense, RPKI for BGP is our only solution at this moment.
Yeah, I have one more question.
Yes.
Thinking further on RPKI, you get into the standard issues of key management, rollover, expiration. What if somebody loses a private key or it gets stolen and you have to reset it? Now you have the whole issue of distributing it, synchronizing it across an entire internet worth of RPKIs. Has this been thought through? Or
I think it's been thought through, and the solutions that are available right now is that the keys are not sent to the network owners themselves. It's basically the regional internet registries managing the keys and providing an interface to the network owners to sign their prefixes. And the benefit of RPKI over, for instance, SSL-TLS is that we are not dealing with a bunch of 100s of commercial CAs. We're just looking at the 5 regional internet registries as the root of trust. So key management is still an issue, but right now that's managed by the regional internet registries, and a rollover is managed there as well.
Well, I'm thinking like an ASN, say for example, it gets its private key stolen. Now it's out of sync. It has to get has to generate a new private key and re-register it with the RPKI, I would assume. So now how do you propagate that to the rest of the ASNs? I mean, becomes a chicken and egg problem.
Yes, it's the same chicken and egg problem.
I mean, the network gets partitioned now. I mean, some know the old one, some know the new one. I mean,
So I have to make sure I understand your question correctly.
So it's a synchronization issue, basically.
So I've not seen synchronization issues with the RPKI validators in my test until now. So I don't. It's probably an issue, but it's a minor issue.
Still too new, huh? Yeah. Okay.
Yeah, and it's still where I mentioned earlier that you can create different levels of trust. So if you have ISPs that you depend on, or ASN owners that you depend on, or that you have a high level of trust with, your routing policies can reflect that trust. So the validation status is not the end-all be-all of BGP security. You can still consider that, for instance, if a trusted peer announces a non-validated route, you can still allow that to propagate based on your own routing decisions. Yeah.
For the YouTube hijacking example, was the attacker able to compromise YouTube credentials? or what's the extent of the compromise?
So that's very, very difficult to estimate. In the case of the YouTube announcement, we have to take into account that it was a non-malicious hijacking situation. So they were looking to limit access to YouTube on the Pakistani internet, right? And they basically, at the time that they started announcing the prefixes, they had access to all the traffic to those prefixes. And whatever they did with it, that's anybody's guess. It's very, very difficult to determine what their goal was, but it's assumed that it was not intentional. Okay, can you speak into the mic? Sorry.
I was just saying the extent of the YouTube one I thought was just a denial of service for YouTube. That the traffic was just dropped because, but then when the latest one that happened with China was the one that was more malicious type because the traffic was actually routed back out.
Yeah, that's right. With Pakistan there was no further routing, but in the China example, they routed the traffic further to the end destination. So there was a full man-in-the-middle situation there. Correct. Okay.
Actually, I have a question. So with the implementation that you're talking about, is there a way to determine that that either whatever route you're taking is fully, supporting RKMS or RPKI, or and to make a determination on that within the software or within your routing?
No, there is no ability right now to validate that your complete ASN path is RPKI validated.
All right, because then if one person's not doing it, then there's they're vulnerable to this, like the BGP poisoning, and then it still could take effect, right?
Yeah.
All right.
No, that's correct. Very good. Well, thank you very much, and I hope you enjoyed the session. I did.